Hey everyone, welcome to the lecture series of Elementary Classical Mechanics, where we will embark our journey from basic to advanced physics. This is lecture number 3. This time we deal with calculus and derivatives for the part 1 of the series. Calculus is must to understand physics and takes good part in physics, and that's why it is important to understand. So let's get started. Here is the graph. On that I draw a line from the equation y equals 2kx, where k is an arbitrary constant, and we select the random point on the line, of course, which are feasible or easy to learn. Now we find the slope, which will be y2 minus y1 upon x2 minus x1. After substituting the respective values of y's and x's, we get the value as 2. And as you can recall from the lecture 1, that slope is delta y upon delta x. It is very important to understand that slope also tells us that the change of y value with respect to the change of x values, or value of y is changing due to the value of x. From here we enter into the realm of derivatives. Now we write the slope as change of y to the change of x, which is obviously delta y to the delta x. As you can recall from lecture 1 that slope is average velocity, except the different variables are. Let us consider a graph here consisting of x and y axis, and I draw a line of equation y equals to kx. On that, let there be a bead rolling around. Now what happens when we need to find the value of y at an exact moment of x? Or in other words, we need to find instantaneous value of y with respect to x. Now in that case, how to find the value of y here, here or here? For that matter, we need calculus via derivative. Consider a point for the position of bead. We use a new mathematical term called as limit. Limit, as the name suggests, is the same thing as its meaning. Or limit we can define as some variable is controlled to an exact extent. Under the limit is change of x or delta x tending to 0. The symbol which looks like an arrow is called as tending towards or approach. So when change of x variable is such that it should be precisely approach towards 0 value in the denominator of slope, then we can find the instantaneous value of y at x. Let me explain properly up next. Let us consider the x-axis where the values are from 1 to 9. Now for that we need to find the value of y at x equal to 5. For that reason the delta x, which is equal to x2 minus x1, must be near to the value of 0, or the difference x must be close to the 0. Now let's zoom the axis such that the range is from 4.9999 to 5.0001. See, the arrows are so far apart, and look at the numbers are so precise. In one question you might be having that, hey man, why can't you take just delta x equal to 0 by obviously taking x1 and x2 equals to 5 and stop wasting our time? Yeah, you are thinking correctly. But there is one thing as precision and another thing as accuracy. They have distinct meanings. In this example, precision is how much number you can put after the decimal point, but accuracy is just that absolute value. In this case, just 5, not 5.0 or 4.9, just 5 is accurate, and 5.0001 or 4.9999 is a precise value of 5. So if we write x1 equal to 5.001 and x2 equal to 4.999, then we get precisely delta x as 0. See, that's why we do not take directly delta x equals to 0, but for the limit delta x is approaching towards 0. For delta y upon delta x, this is an important concept and must be understood clearly. And then instead of writing the whole form of limit, we just write dy by dx, or the way to say is differentiation of y with respect to x. In this lecture, we have learnt about overview of theory of derivative. First, we understood what is the significance of the slope for a change in function with respect to particular variable. Then from that slope, we made the denominator of this slope to approach towards the zero. Thus, we introduced limit. Then after understanding limit, we arrive at the final stage, that is how the denominator change approaching towards zero gives birth to the instantaneous change in function, that is dy by dx. The part 2 of lecture number 3, we will learn about the formulas to perform mathematical operation using derivative. I upload video lectures within a week or two. Please remember to subscribe the channel. Your gracious subscribe will help me to create more quality lecture series. Phi Shastra will have the playlist of classical mechanics, and for continuing the lecture, please click on the floating card. Thanks and stay tuned.